Welcome to the deep dive. Today we're tackling a big one. Electric cars versus, well, the regular gasoline ones we've driven forever, the internal combustion engine vehicles, or ICEs.
Yeah, it's a huge topic, and there's a lot of noise out there.
Exactly. And if you're listening, you want the real story, the environmental picture, but, without getting totally lost in the weeds.
Right. Fast, but thorough.
That's the plan. We're doing a full life cycle look. What does that actually mean for the planet when you compare these two types of cars?
It means looking at everything, from digging the raw materials out of the ground.
Like for the batteries or for the oil?
Precisely. All the way through manufacturing, driving the car for years, and then what happens at the end of its life.
So way beyond just what comes out of the tailpipe.
Absolutely. Tailpipe emissions are important, obviously, but they're just one piece of a much bigger puzzle.
Okay, let's dive in then. Where do we start? Maybe the big number, CO2 emissions.
Good starting point. So if you look at the whole life cycle, right now in Europe, an average EV produces about 55% less CO2 than a comparable gasoline car.
55%, that's pretty significant. Over the car's whole life.
Over its entire life, yes. And here's the kicker. That gap is only going to get wider.
How so?
Because our electricity is getting cleaner. As we add more renewable solar, wind to the grid, the emissions associated with charging your EV go down.
Ah, right. So the fuel source for the EV gets greener over time.
Exactly. Projections suggest that by 2050, that advantage could jump to maybe 80% less CO2 compared to a gasoline car.
Wow. Okay. But let's talk about the batteries. This thing people always bring up, the environmental cost of making them.
It's a valid concern. Making EV batteries does have an upfront environmental footprint. You're extracting minerals like lithium, cobalt, nickel.
Yeah, you hear about the mining, the water use.
And it's true, there are emissions and water consumption involved. No way around that initial hit.
So that offsets the benefit.
Well, no. And this is the crucial part. That initial impact, while real, is generally offset, often quite significantly, during the use phase of the car.
Because the EV isn't burning gasoline while you drive it.
Correct. Zero tailpipe emissions while driving. Plus, electric motors are just way more efficient. They convert more electricity into movement compared to how much energy a gasoline engine actually uses to turn the wheels.
Okay, so it's like an environmental debt you pay up front, but then you make gains back over the years of driving.
That's a good way to put it. And there's another factor. Recycling.
Right. What happens to the batteries at the end?
Well, the valuable materials in them, the lithium, cobalt, nickel, they can be recovered and reused in new batteries.
So it's not just a one-time use for those mined materials.
Ideally, no.
So.
Improving recycling reduces the need to constantly mine new raw materials, which further lowers that long-term environmental impact.
Okay, that helps balance the picture. Now let's flip it. What about the hidden costs of gasoline cars? We're so used to them, maybe we don't think about it.
We often don't. Think about the journey of gasoline. First, you have to find and extract crude oil drilling, sometimes in sensitive areas, potential spills.
Yeah, the big oil spills get headlines, but there are probably smaller issues constantly.
Exactly. Then you transport it, often globally. Then it has to be refined, which is a very energy-intensive process itself. More transport to the gas station.
It's a whole chain reaction of impacts before it even gets into the car.
Precisely. And unlike battery materials, which can potentially be recycled, once you burn that gasoline, it's gone. It becomes CO2, other greenhouse gases, pollutants, straight into the atmosphere. There's no getting it back.
It's a finite resource turned into pollution.
Okay.
And then the actual driving. We touched on zero emissions for EVs, but what are IC cars putting out?
While driving, EVs produce zero greenhouse gases and zero local air pollutants. That's a direct win for air quality, especially in cities, and for public health.
Cleaner air, fewer breathing problems.
Potentially, yes. ICE vehicles, meanwhile, are constantly emitting CO2, which drives climate change, but also things like nitrogen oxides, EOX, particulate matter, those tiny soot particles, carbon monoxide. It's stuff that's directly harmful to breathe.
Right. And you mentioned efficiency earlier. Can we quantify that a bit more?
Yeah, the difference is stark. An EV typically converts around 90% of the electrical energy from the battery into power at the wheels.
90%. Wow.
Compare that to an internal combustion engine. It's maybe around 20% efficient at converting the energy in gasoline into motion.
20. Where does the rest go?
Mostly wasted as heat. Think about how hot an engine gets. That's lost energy. So EVs are just fundamentally much better at using the energy they're given.
So less energy wasted overall, even considering how the electricity is made.
Generally, yes, especially as the grid gets cleaner. That improving grid is key. The environmental footprint of charging an EV today is lower than it was 5 years ago, and it'll likely be lower still in 5 more years.
So the trend is definitely moving in favor of EVs from an environmental standpoint.
The data strongly suggests that, yes.
Okay, this is really helpful context. But going back to that initial battery issue, the resource extraction, I actually read something interesting about lithium recently, a potential new way to get it.
Oh, lithium extraction is definitely a focus area for improvement. What did you hear?
It was about getting lithium from underground brines, salty water. Apparently, there's a new method that could be way cheaper, maybe half the cost, and much more sustainable.
That sounds promising. The current main method for brine involves those huge evaporation ponds, right?
Exactly. Apparently, they take up massive amounts of land, rely totally on the climate, sun, and wind, and can take months, even years to produce lithium.
Yeah, it's effective, but has significant drawbacks: land use, water loss, time. So what's this new approach?
It's called, let me get this right, Redox-Couple Electrodialysis, RCE.
Electrodialysis, so using electricity in membranes.
Kind of. It uses a small electric current and a special type of membrane, an electrolytic one, to pull just the lithium ions out of the brine. It moves them from the weak brine into a separate stream that gets more and more concentrated.
So a direct extraction method rather than waiting for water to evaporate. DLE, direct lithium extraction, is a hot area.
Right, and this RCE seems particularly efficient. They ran lab tests continuously for over 100 hours.
And the results?
Really good, apparently. Very low energy use, like less than 10% of the electricity needed for current tech, they claim. And it's super selective, grabbing almost only lithium, like 99.5% selective.
Less than 10% of the power and nearly perfect selectivity. That's potentially game-changing if it scales up. Lower energy means lower emissions and lower costs.
And they did test a bigger version, 4 times the size, and it reportedly worked just as well. So they think it is scalable.
That's the critical step, moving from the lab bench to industrial reality.
Yeah. And the potential benefits they list are pretty compelling. Lower capital costs, getting rid of those giant ponds, using way less electricity, water, and chemicals.
So a technology like this could directly tackle some of the biggest environmental question marks around battery production, makes the whole EV proposition even stronger.
Exactly. It ties back perfectly.
Yeah.
So when you bring all these threads together, the battery production impact, the much lower lifetime emissions, the efficiency, the recycling potential, and these new technologies emerging.
The overall picture really does favor EVs, especially looking towards the future. The initial environmental cost of the battery is real, but it's outweighed by the benefits over the vehicle's life. And those benefits are growing as electricity gets cleaner and technologies improve.
You really do have to look at that full life cycle, don't you? From cradle to grave, so to speak.
Absolutely. It's the only way to make a fair comparison. And considering everything, including the potential for better resource extraction like that RCE method, EVs seem like a critical path towards cleaning up transportation.
It really shifts the perspective. It's not perfect, but the overall trajectory looks much more sustainable.
Definitely. Which leaves us with a thought, maybe for you listening. How much further can these innovations go? Think about how advancements in getting materials like lithium and the ongoing greening of our energy grids will continue to reshape just how sustainable our cars can be in the coming years.
A lot to think about there. If this deep dive sparked your curiosity, definitely give us a like and subscribe for more explorations like this. Thanks for joining us.